this video, I'm going to be talking about permutations and going over a couple of examples on how to find permutations or arrangements whenever they are giving us a situation with different options, right? And when the way that we choose these options matters, the order in which we choose it matters. So for this one, it says that a school musical director can select 2 musical plays to present next year. One will be presented in the fall and one will be presented in the spring. If she has 9 to pick from, how many different possibilities are there? So on this problem, we can see that she cares about the order in which she's going to choose the plays, right? Because there's one that's going to be presented in the fall and the other one will be presented in the spring. That means one's going to be presented first and the other one's going to be presented later, right? We care about the time, we care about the season. So she is concerned about the order in which she's going to choose and pick and place the different musicals, right? So yes, the order matters for this particular situation. The order matters since we have a fall and a spring play, right? Because of that means that we're going to be using permutation. So going back to the formula, right, for permutation, we know that the formula is n and then pr equals n factorial over n minus r factorial. N is basically the total number of objects or elements or options that we have, and R is how are we choosing them. So the different places that we have in order for the order, right? So N is total, R is, let's say I'm gonna call it places. So number of places, right? In this case, it'll be number of plays that are actually going to happen in a year. So my n equals 9 and r equals 2, because just choosing 2 musical plays out of the 9. So this will be 9p2 equals 9 factorial over 9 minus 2 factorial. And this becomes 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 9 times 2 is 7 factorial, right? So 7 times 6 times 5 times 4 times 3 times 2 times 1. So this right here became 7 factorial. So notice how from what we have here, 7 will cancel out, and 6 and 5 and 4 and 3 and 2 and 1. So all of those values cancel out and we're left with 9 times 8, which is equal to 72. That means that there are 72 different possibilities for the musical director to choose from. So this is one example of finding permutations, and again, you have to pay a lot of attention on what it's being told to you, and making sure that we know that the order in which we are selecting whatever we're working with, our selections, right, that the order matters, right? If we notice that they're just asking how many groups instead of, like how many different arrangements, then that'll be a different case. If we don't really care of which play goes first and which one goes next, then we wouldn't be working with permutations. However, in this case, because we do care about which play will be on the fall and which one will be on the spring, then this will be a permutation. Okay, here's another example. So this one says that a radio talk show host can select 3 of 6 special guests for her program. The order of appearance of the guests is important. How many different ways can this be done? So again, in this one we have this radio talk show host, and she is going to be selecting 3 of 6 special guests for her program, and they are specifying that the order of the appearance of the guest does matter, right? How many different ways can this be done? In how many arrangements can we put the special guests, right? And again, super important, order matters. So that's what's telling us that this is going to be a permutation. So order matters. So then this is a permutation. That means that we're going to be using, again, the formula NPR equals n factorial over n minus r factorial, where n is the total number of guests and r is the number of guests that are going to be selected. So we have 6 in total and 3 that are going to be selected, so that's going to be 6 factorial over 6 minus 3. Now this one I'm going to do it a little bit different than the other one. I'm going to leave the 6 factorial, and then 6 minus 3 factorial is 3 factorial, right? So 6 factorial becomes 6 times 5 times 4 times 3 factorial over 3 factorial. Notice how I stopped at 3 factorial. Reason is I have on the bottom 3 factorial as well, so what I can do is just cancel out. So instead of writing and expanding everything out the way that I did it on the previous problem, I can just go ahead and stop on the same factorial that it's on the bottom and cancel out. So then we are left with 6 times 5 times 4, which is 6 times 5 is 30, times 4 is 120. So there's 120 ways in which the host can arrange her 3 special guests out of the 6.